Hi guys, welcome to my first ever YouTube video on my channel. My name is Adrian Corral, and today we're going to be going over networking and communication systems. What is the internet, right? So what comes to mind when you think of the internet? To simply put that, the internet is a network of networks. It is a global system that connects billions of computing devices through packet switches and communication links. This allows data to travel from one point to another. Whether you're streaming a video or sending an email, these actions happen through this network. So there are many examples of what a network can be. Some throughout your daily life could be through the Internet of Things, which, as some examples I have right here on the side, it could be like an Amazon Echo, gaming systems, and smart appliances. All these things use networks to connect to the internet. The internet is made up of multiple interconnected networks. There are protocols everywhere that must be followed and kept up with the internet standards. Devices connect to the internet through ISPs, internet service providers. The ISPs are also interconnected, making a web of networks, which ends up making a very complex ecosystem of sorts, which makes it rely on each other. In network components, the network edge is a very important part. This includes clients and servers, which are located in data centers, right here. They are connected to the edge of the network, allowing users to access and transfer data. So how do systems connect to edge routers? This is done through residential access networks, institutional networks, and mobile access networks. These networks act as bridges that connect devices to the internet. Home networks. At the center of the home is a router. The router connects to the internet by an ISP and acts as a gatekeeper, directing internet traffic between your devices and the internet. Wireless access networks have two main wireless local area networks. So like your home Wi-Fi and wide area cellular networks like 4G or 5G on your smartphone. These wireless connections allow you to connect to the internet without any actual physical cables. Access networks in enterprise. Enterprise networks like companies and universities use networks that are a mix of wired and wireless connections. They may involve switches and routers to handle traffic within the organization, ensuring a connection. The core of every network is a mesh of interconnected routers. These routers will use something called packet switching, in which they move data from one point to another. Each packet is forwarded from one router to the next until it reaches its destination. There are two key network core functions, forwarding and routing. What forwarding does is it involves moving packets between routers, while routing, it determines the best path for packets to travel. So let's look at an example here. So to help you guys understand, we're going to look at a way you can compare this to daily life. For example, setting a route when you're going on a road trip. I want you to look at forwarding as the actual action of driving down the interstate and routing as the directions you will take to get from point A to point B. Packet switching, store and forward. So when trying to send data out, it takes some time for it to arrive at its final destination. Well, packet transmission delay is essentially the amount of time it takes for a packet to be pushed out. And what store and forwarding means is that the entire packet must arrive at the router before it can be transmitted onto the next link. When looking at packet switching, there is something called queuing that you may or may not have heard of. What this is when work ends up arriving faster than it can be serviced. So look at it as waiting in line for something. You can be waiting for the bus or waiting in line for traffic. Packet switching is sending small chunks of data called packets, which are stored and forwarded by routers. But there is another method called circuit switching, where resources are allocated for the entire duration of a communication session, like in telephone networks. What is a protocol? Well, let's look at a human protocol and a computer network protocol. So here we see a woman and a man. The woman says hi to the man, and the man responds by saying hi back. The woman then asks the man what time it is, and the man responds by telling her the time. Let's look at a computer network protocol. The computer requests a connection to the server, and the server sends a response. The computer then clicks on the link, and the server sends the corresponding file. So what we see here is a question-answer relationship. Protocols define the format, order of messages sent and received among network entities, and the actions taken on message transmission. One important aspect of networking is performance. Delays and packet loss can happen when routers end up being overwhelmed. leading to it getting congested. Understanding how these factors impact efficiency is important to optimizing performance. If too much data is in the queue, the data will be dropped, leading to loss. Packet delay has four sources. One is nodal processing, which is when it checks for any bit errors and determines the output link. Second is queuing, which we have just gone over in the previous slides. The third is transmission delay, which is the packet length and the link transmission rate. And the fourth is propagation delay, which is the physical link and propagation speed. So to help you guys understand better, let's look at this through a caravan. Let's say the data you send are 10 cars on a highway. Each car has to go through an initial toll booth that takes 12 seconds for each car to go through. Then they have to travel 100 kilometers to reach the next toll booth. Now let's say that the cars are traveling at 100 kilometers per hour. It would take the caravan 62 minutes to reach the second toll booth. This will repeat until the caravan, your data, reaches its final destination. Another important concept is throughput, which is the rate that data is successfully transmitted through a network. It is measured in terms of bits per second, and the higher the throughput, the more data can pass through. Originally, when the internet was first created, it was designed with very little security. But now in modern times, there are always constant threats that need to be combated to keep the internet and its users safe. Now, things that need to be taken into account are how bad guys can attack computer networks and how we can defend networks against attacks, and especially how to design networks that are immune to attacks in the first place. Now let's go in depth about packet interception. This is when a bad guy intercepts packets of data as they travel through the network. This is a serious threat because these intercepted packets contain sensitive information such as login info, financial details, or private messages. Another major threat is identity spoofing or using a fake identity. This involves a bad guy pretending to be someone else to gain access to a network in which they can steal data or pretend to be a user. One of the most disruptive attacks that networks face is denial of service. A bad guy overwhelms a server with so much traffic that users can no longer access it. Think of it like a traffic jam. So many cars are trying to get on the highway that no one can move. We use multiple layers of security to protect networks from bad actors. Authentication verifies the identity of users. Confidentiality ensures data remains private. Integrity checks to make sure data isn't changed in transit. Access restrictions control who can enter certain parts of a network. And firewalls act as a first line of defense, filtering traffic and blocking unwanted access. Well, I want to thank you guys for watching, and I hope you enjoyed it and were able to learn something new. I'd really appreciate it if you guys left a like and subscribed, and I'll see you guys in the next video. Thank you.